Hello everyone. So in this short video, we will try to discuss about the basics of the transistor. Transistor is a semiconductor device and basically it consists of two p-n junctions in it, and it is formed by sandwiching either p-type or n-type semiconductor between a pair of opposite types. Okay, so this transistor is invented in Bell Laboratories in long back, and this is one of the very important semiconductor device having many applications in the field of electronics. So basically there are two types of transistors. One is NPN transistor, another one is the PNP transistor. Basically these NPN and PNP transistors are obtained by sandwiching a N-type material between two P-type materials, that PNP transistor, and this NPN transistor is okay. So this is how PNP and NPN transistors are formed by sandwiching P-type or N-type semiconductor between pair of opposite types. So this is the definition of the transistor. Let us discuss in detail about the NPN and PNP transistor. This NPN transistor is composed of two N-type semiconductors on both sides of the thin section of P-type. Whereas in PNP transistor, two P regions are there, and in between them there is a very thin N region. That is PNP transistor. In a NPN transistor, there are two N-type semiconductor pieces. In between them, there is a P-type semiconductor piece. Okay, so this is the structure of NPN transistor, and this is the structure of PNP transistor. So these three regions are connected by means of wires. Because of that, this transistor contains three terminals in it, and also it contains three regions in it. This is one region, second region, and third region. And what are the names for them, and what are these terminals are called, that will be discussed in the next slide. So basically this NPN transistor, in NPN transistor, there are two PN junctions. This is one PN junction. This is another PN junction. They are connected such that these two PN junctions are connected back to back. Okay, so three regions are there, three terminals are there, and two PN junctions are present in the transistor. That is the important property of the transistor. So there are three terminals. Because of that, this transistor is said to be three-terminal semiconductor device. And basically, the middle section is very thin layer, and that is called as base of the transistor, and that takes very important factor in the function of the transistor. We'll discuss that while discussing the working of the transistor in the next section. So here we have to remember that transistor contains three semiconductor regions, and it contains three terminals coming out of each region, and transistor has two PN junctions in it. This is one PN junction. This is the second PN junction. Okay. So middle region is very thin, and that is having very important function in the working of the transistor. So naming of the transistor terminals, how these transistor terminals are named. In a transistor, either it is PNP or NPN, it has three sections of doped semiconductors. Okay, so in PNP transistor, there is a middle region of N-type semiconductor, and other two regions are P-type. In NPN transistor, two regions are N-type and middle region is P-type. Okay, the section on one side is called as emitter. Usually on the left-hand side is called as emitter. The section on the right-hand side is called as collector. Okay, so in a transistor, this left side region is called as emitter of the transistor. The right side region is called as collector of the transistor. Okay. The middle thin section is called as base of the transistor. Okay, so this base forms two PN junctions. Okay, joining with this emitter and collector. So basically, these two junctions are formed, and these three regions are called as emitter, base, and collector regions. Okay, and these three terminals are also called as emitter terminal, base terminal, and collector terminal. Okay, emitter terminal, base terminal, and collector terminal. So in PNP transistor, emitter is P-type, base is N-type, and collector is P-type. In NPN transistor, emitter is N-type, base is P-type, and collector is N-type. Okay, so this is how you can name the three regions of the transistor as emitter, base, and collector. Okay, you have to remember that the three regions of the transistors are called as emitter, base, and collector. And there are two PN junctions. One is emitter base junction, another one is the collector base junction. Okay, we'll discuss that. So what is the main important properties of the emitter and what is the function of the emitter? Basically, emitter is situated on one side of the transistor and its function is to supply the charge carriers. Okay, so emitter is basically provides the charge carriers required for the conduction. This emitter is heavily doped so that it can produce large number of charge carriers. So heavy doping means more and more impurity atoms are added. So impurity atoms will provide the required number of charge carriers. So here charge carriers may be electrons or holes. If emitter is N-type, it produces electrons. If emitter is P-type, it produces holes. So question may be asked, why emitter is heavily doped? The emitter is heavily doped because emitter has to supply the required number of charge carriers for the conduction purpose. That is the reason why it is heavily doped. Coming to the base region of the transistor, it is the middle section and it is very thin section of the transistor. It forms two PN junctions between emitter and collector. Okay, middle region is base and on either side there is an emitter and collector in it. So basically this base is very much thinner compared to emitter and collector, and also it is lightly doped. The lightly doping of the base is because of the reason that it should not carry more charge carriers in it. It has to act like a medium of transfer of charges from emitter to collector. Okay, so we'll discuss that while discussing the working of the transistor. So basically this base passes most of the emitter injected charge carriers to the collector. It will not take the charge carriers in it, just it acts like a medium to pass the charge carriers from emitter to collector. That is the middle region called base. The third region is called as emitter. So this collector. So collector is actually, it collects the charges coming from the emitter. That is the reason why it is called as collector. Collect means to collect the charge carriers. So this collector is moderately doped. It is not too heavy, not too light, because it has to collect as many charges as possible, and it will conduct the electricity because of that. Compared to the emitter and base, the size of the collector is large because it has to provide large area to collect the charge carriers. Okay, so these three important regions, compared to the in comparison with the size, base is very thin, collector is very large, and emitter is basically the moderate size. Coming to the doping percentage of the emitter is large and doping percentage of the base is very, very light, and collector is moderately doped. The function of the emitter is to supply the charge carriers uh, for the conduction purpose. Base acts like a medium of conduction process, and collector will collect the charge carriers coming from the emitter. Okay, so this is how emitter, base, and collector are shown in the transistor. Here I have shown the PNP transistor. Now this transistor has two p-n junctions, and we call these junctions as emitter base junction and collector base junction. Okay, so here we call this junction as emitter base junction. The second junction is called as collector base junction. Okay, so basically for the proper working of the transistor, there are two important conditions that has to be satisfied. One is emitter base junction should be forward biased. Okay. Secondly, the collector base junction should be reverse biased. So emitter base junction should be forward biased. Collector base junction should be reverse biased. So in both PNP and NPN transistor, these two conditions has to be simultaneously satisfied. Then only the transistor works properly. Okay. So for that particular condition, so you can make use of two batteries. So one battery, this battery is used to forward bias the emitter base junction. Okay, this is emitter, this is base. The junction between them is called as emitter base junction. So this junction has to be forward biased. Okay. So in this PNP transistor, emitter is P type. So to forward this emitter region, this P type has to be connected to the positive of the battery. P type to positive, P to P. And base is N type. This N type has to be connected to the negative of the battery. This is how this battery makes the forward biasing of the emitter base junction. The second battery used here is basically reverse biases the collector base junction. Here collector has to be reverse biased. So collector is P type. That's why it is connected to the negative of the battery. Base is N type, and that is connected to the positive of the battery. Here emitter base junction in NPN transistor is forward biased, where emitter is N type, that is connected to negative of the battery. Base is P type, that is connected to positive of the battery. To reverse bias the collector base junction, the second battery is used. Here N type collector is connected to the positive, N to P, that is reverse biasing of the collector base junction. Okay. So this is how the forward biasing of the emitter base junction and reverse biasing of the collector base junction can be done using batteries. And these two important conditions are required for proper working of the transistor. So here basically we have shown the corresponding forward biasing and reverse biasing of the batteries transistor. Emitter and base junction, it is forward biased. Collector base junction is reverse biased. So you know that when the junction is forward biased, the charges will flow through the junction easily and resistance of the junction will be very small. When the junction is reverse biased, basically the current or charges will not flow through the junction. Okay. So basically forward biased junction supplies the charges to the base. So emitter base junction is forward biased. Because of that, the charges can flow from emitter to base easily. Okay. Secondly, the collector base junction is reverse biased. Because of that, this actually removes the charges from its junction with the base. Basically, all the charges will be attracted by this battery. So collector tries to receive more and more charges from the emitter. Okay. This is how the charges will flow from emitter to collector through base. Okay. So here I try to discuss the transistor action, how transistor works. Okay. So basically, this emitter base junction is forward biased in this NPN transistor. Okay. So here this battery VEB is connected so that its positive terminal to base region, negative terminal is connected to the emitter region. Emitter is N type. Because of that, this PN junction is forward biased. When PN junction is forward biased, basically the majority charge carriers in the emitter will move towards the base easily. So more and more electrons will be transferred to the base through this PN junction. Okay, the forward bias causes the electrons in N-type emitter to flow towards the base. As these electrons flow to the P-type region of the base, they tend to recombine with the holes. Okay, so some of the electrons will recombine here, and because of that, the base current IB flows through the base terminal. And it is observed that this base is lightly doped and it is a very thin region. Because of that, there is no more space for the recombination of the electrons and hole. So because of that, only 5%, less than 5% of the electrons may recombine here, and 95% of the electrons will move towards the collector region, because here collector is reverse biased. This is N-type, and that is connected to the positive of the battery of VCB, and these electrons present here will be attracted towards the positive terminal of the battery. So 95% of the electrons will be attracted here towards the collector terminal, and that will constitute the collector current IC. Okay, so these arrow mark indicates the direction of flow of electrons, and direction of the flow of current will be in reverse direction. So IE is due to the electrons which are flowing from emitter to base. IB is due to the recombination of the electron hole pair, and that is only 5%. And 95% of the electrons will cross to the collector region. So that means most of the electrons coming from the emitter will move to the collector region through the base. Okay, this is how this transistor works. Okay, so basically in a transistor, the electrons in the emitter will move towards the collector through the base region. Okay, and here if you observe, emitter current which is flowing out of the emitter terminal, that is due to the base current and collector current. Okay, so basically it is observed that the emitter current IE is always equal to the sum of base current and the collector current. Okay, and that is well applicable for both NPN and PNP transistor. Okay, so basically the number of electrons coming from the emitter will be utilized in base. Only 5% will be utilized in base, and 95% of the electrons will move towards the collector. Okay, because of that, the total current IE, emitter current, will be always equal to the sum of base current and collector current. And this base current is very small. It is of the order of microamperes, and collector current will be nearly equal to this emitter current. Okay, so that is how this emitter current is nearly equal to the collector current, and base current is observed to be very small compared to the collector current. That you have to remember. So importance of the transistor action. Basically, in case of transistor, the emitter base junction is forward biased. Because of that, it offers very low resistance for the input. So basically, emitter is input and collector base junction is the output. So collector base junction is reverse biased. So when it is reverse biased, it offers very high resistance. Basically, as you have seen that the input emitter current is almost equal to the collector current. That means the input current, which is emitter current, is basically flowing from the low resistance region to the high resistance region. Okay, because collector is reverse biased, it offers high resistance. Emitter is forward biased, it offers low resistance. Therefore, in a transistor, the signal is flowing from low resistance region to the high resistance region. So this is the very important factor for amplification capability of the transistor. So basically, when a signal is transferred from low resistance to high resistance region, automatically the voltage will increase according to Ohm's law. The same current is flowing from low resistance region to the high resistance region. Because of that, the voltage will automatically increase. That is in accordance with the Ohm's law. So how transistors can be represented in a circuit? So this shows the circuit symbol of the transistor. Here I show the NPN transistor. So here the current IE, that is emitter current, is flowing out of the transistor, and base current and collector current are incoming current to the transistor. Okay, and we know that this emitter current is always equal to sum of base current and collector current. So when these two currents will come into the transistor, they will join together, and that will flow out of the transistor as a emitter current. So this is how the direction of current is like this. So current is flowing in anti-clockwise direction. Okay. So same thing is shown in the transistor symbol also. So transistor symbol consists of a straight line, and at the middle we'll draw one straight line that is representing the base, that represents the middle region base. Okay. So and two slanted lines on both sides are written here. This is one slanted line. This is the another slanted line. So they are symmetrically written, and this terminal is containing an arrow mark. Okay, the terminal which is containing the arrow mark represents the emitter, and this direction of the arrow mark represents the direction of the flow of current. And these two terminals are not written with the arrow mark. Only this terminal is containing the arrow mark that is actually representing the emitter. So emitter is represented by means of the arrow mark in the transistor symbol. So direction of the arrow mark represents the direction of current. Here it is shown that the emitter current is outgoing like this, and collector current and base current are coming into the transistor. And this circuit symbol is usually written inside the circle. Okay, a straight line, middle region is shown at the middle, and two slanted lines are written, and one slanted line is written with the arrow mark. Okay, so this circuit symbol is the NPN transistor circuit symbol. So in PNP transistor, basically the emitter current is incoming, base current and collector current are outgoing currents. So that is how the current in PNP transistor flows in clockwise direction like this. Okay, again here, emitter current is equal to the base current plus collector current. So similar circuit symbol is used. Only thing is the direction of the current is reversed. So arrow mark is going inward. Again, a straight line with middle terminal representing the base. Two slanted lines are written, and arrow mark is shown here. So this arrow mark shows the direction of the current in PNP transistor. If arrow mark is going out, it is NPN transistor. If arrow mark is coming in, that is representing the PNP transistor. Okay. So this is about the basics of the transistor and its working. So in the next video, we'll discuss about the transistor characteristics.